All right, gang, this lesson is for confidence intervals for population proportions. So it's this one's to find the minimum sample size. That's the new part about this one here. So let's do a review from yesterday's lesson, you guys. So here's one. In a survey of 498 U.S. adults, that would be N. A question was raised: who are the more dangerous drivers? And so 71% thought that teenagers were, while 25% thought that people over 65 were, and then 4% had no opinion. So they want us to construct a 99% confidence interval for the population proportion, which is p hat, is going to get involved. So population proportion is p. So, of U.S. adults who think that teenagers are the most dangerous. Okay, so the teenagers was 71%. So our p hat for this sample, the p hat goes with the proportion from the sample, is 0.71. So q hat is 1 minus that, so 0.29. So we have to check to make sure that n times p and n times q is greater than or equal to 5. So if we do that, we do find out that both of them are greater than or equal to 5. All right, and it said a 99% confidence interval, so our z-score is 2.575 for a 99% confidence interval, and n is that 498, okay? So our margin of error, remember, is our z-score, and then times the square root of p hat q hat divided by n. So we'll just plug them in, and we get, and that's the number that we add or subtract to our p hat, okay? So when we crank all that out, we get about 0.052. So our 99% confidence interval is p hat plus or minus that 0.052. Okay, so if we do that, here I'll just move it up, and we get that right there. So let's interpret the results. Okay, so with a 99% confidence, we can say that the true population proportion of U.S. adults who think that teenagers are more dangerous drivers is somewhere between 65.8% and 76.2%. All right, so finding a minimum sample size. Here's the new part to estimate P. Okay, so given your C confidence level, the last one was 99%, and they're given our margin of error, they're going to give us a margin of error, the minimum sample size n that we need to establish the population proportion is, it's just your margin of error worked backwards. So remember we did that a few lessons ago, and we did that square root one. So we're looking for n right there. So it's p hat q hat times the z-score divided by the margin of error squared. Okay. So now this formula assumes that we have preliminary estimates of p hat and q hat. If we don't, then we use 0.5 for both of them. Okay, so sometimes they give them to you, sometimes they don't. Here's an example. So you're running a political campaign and wish to estimate the 95% confidence, the population proportion of the registered voters who will vote for your candidate. Your estimate must be accurate within 3%, so there's our margin of error, of the population proportion. So find the minimum sample size needed when, there's two cases, when no preliminary estimate is available, and the second part is when the preliminary estimate is 31%, and compare these results. Okay, so the first part says we don't have the preliminary estimate, so we're going to use 0.5 for the p hat and q hat, okay? So we're going to use our z-score, 1.96 for the 95% confidence interval. Our margin of error is at 0.03 because it's 3%, and we can solve for n, okay? So put 0.5 here, 0.5 here, the 1.96 and the 0.03 here, and plug it in. So we have to do this divided by this first, square it, and then you multiply times 0.5, and then again times 0.5. So we get about 10,067 with some change. So because it's a decimal, we always round up. That makes it safer. Okay, so our nearest whole number is 1,068. Okay, so let's do 2. So now we have the preliminary estimate of 0.31. So the 1 minus that is 0.69. So we're going to go ahead and plug that in and crank it out, and we get 913. So we're going to round that up to 914. Okay. All right, and then it says compare the results. Okay, so what we can say is with no preliminary estimate, the minimum sample size should be at least 1,068 registered voters. And when we had a preliminary estimate of 31%, the sample size should be at least 914 registered voters. So we need a larger sample size when there's no preliminary estimate that's available to be accurate. All right, if you are in my class, that would be your assignment. Take care. It's a class next door, so it's my prep period.